Hi guys, and welcome back to Unimig. When you're learning a new skill or facing a new situation, you're probably going to run into some issues while you're getting a handle on it, but that's fine. Being able to identify what the problem is and knowing how to remedy it can save you a lot of head scratching and frustration. Today we're covering the most common problems you might encounter when welding. We'll show you how to recognize them and help fix them to prevent them in the future. If you want to jump ahead to a specific problem covered, be sure to check out the timestamps. Porosity occurs when elements in the atmosphere are absorbed into the whirlpool while it's still molten. These gases become trapped once the metal solidifies and you're left with a weld full of holes. Porosity is often referred to as Swiss cheese because of the little bubbles left behind. So what causes it? Dirty parent metal, not enough shielding gas, the wrong type of shielding gas, contaminated gas, incorrect torch angle or position, and for stick welding, you could also have damaged electrodes or moisture in the electrodes. So how can you prevent it or fix it? Thoroughly cleaning your parent metal and give your filler a wipe down. Clean your consumables and replace any that are worn or damaged. Also make sure your equipment is moisture free. Check out your gas flow on MIG or TIG. Unimig recommends 8 to 12 litres a minute, and also make sure it's not leaking or empty. Check you have the correct type of gas. Argon CO2 for MIG, stainless and steel, pure argon for MIG aluminium and TIG. Angle your torch 45 degrees and roughly 3mm off the joint for good positioning. If there is a draft or you're outside, set up some makeshift walls to block the wind. There are 3 types of cracks that you can get. Hot cracks, when the strain on the whirlpool is too high or is forced to cool too fast, hot cracks occur. Cold cracks, not very malleable material, residual stress from consistent vibrational flexing and diffusible hydrogen inside the metal can all create cold cracks. Crater cracks, when the end of a weld isn't filled properly, a weak point forms and can crack. Sometimes a crack won't immediately form, and it's not until days, months or years later that the metal begins to crack. Once it's there though, it'll only get bigger. The problem with cracking in a weld is that you can't just go back over the top of it and fill it in. You have to remove the part of the weld, or the entire weld, and restart from scratch. If you can prevent the crack from forming in the first place, then it's going to save you a whole lot of time and effort. So what causes it? The wrong type of shielding gas. Shocking the metal, which is caused by not cooling it slowly enough under shielding gas. Using the wrong type of filler metal. Not filling the joint in properly, especially at the end. This will cause a crater crack. Poor joint configuration and preparation. How can you prevent or fix it? Use the correct type of gas for your metal type. For TIG, cool your metal slowly using an appropriate amount of post-gas flow for your weld. Preheating and post-heating your metal so that the temperature range isn't so severe. Make sure your filler metal, tensile strength and metal grade matches or is as close to as possible to your parent metal. Use a backfill method to add extra filler at the end of your weld and let the weld build up slightly to prevent craters. Clean, grind, deburr, bevel and clamp your joint so that it's lined up as tight as possible with no impurities. If a crack has formed on your weld, you'll have to grind the whole thing off and restart. Undercut occurs when a weld gets too wide and the base metal dips in along the edges due to poor welding technique, but there is not enough filler material to fill in the gap, so you're left with a groove on the toes of the weld. So what causes it? Arc length is too long, too many amps or too much heat, not adding enough filler, too fast of a travel speed, or angling the torch too far in the one direction. How can you prevent or fix it? Well, make sure to keep a tight arc. Lower your amps and heat so that you're not excessively digging into the joint. Slow your travel speed down so there is enough time to fill in the joint properly. And keep your torch tip centered in the middle of the joint or towards the thicker metal. If the pass is wide or you've got an undercut, use multiple passes to fill it back in. Overlap is pretty much the opposite of undercut. There's too much filler in the weld and the machine is running too cold, so it's not enough amps. The type of joint you're working on will determine whether you've got overlap or not. A fillet weld, on the other hand, should be miter, flatten the joint. Either way, the beads should be fused into the edges rather than hanging over them. So what causes it? Too much filler metal, incorrect welding technique, not enough heat, as in amps and volts. How can you prevent or fix it? Use less or smaller filler wire. Make sure that you're welding at the correct angle with a good arc distance. Increase your volts for MIG or your amps for TIG and stick. Distortion can also be referred to as warping, in which the material hasn't been able to cope with the expansion and the contraction that comes with heating and cooling. It often looks as though the metal has begun to pull and warp. A lot of the time, it means that there's too much heat in the plate, not just the joint, which the metal can't handle. So what causes it? Too much heat. Traveling too slowly, not clamping enough, or not enough tacks. How can you fix or prevent it? Where possible, do short welds or stagger welds. Increase your travel speed, but up your amps so the puddle still forms, so less heat sinks into the parent metal. If you're working on thin sheet metal, spot welds or staggered welds can spread the heat. Weld on both sides, the metal will often pull towards the weld. Welding the opposite side will pull it back. Clamp your piece correctly. Use turnbuckles and lots of clamps if needed. Also use lots of tacks. Metal is always going to warp, even if it's just slightly. Once there's heat in it, the important thing is to minimize the amount of distortion, especially on critical welds. If you do end up with warped metal, you can go back to reheat it to fix it. There are plenty of ways to reshape it, such as using a hammer and a dolly. Burn through is literally burning through the metal so that the filler protrudes out the other side, or in more extreme cases where you're left with a hole. So what causes it? Too much heat in one concentrated area. For TIG and stick, your amps could be set too high. For MIG voltage ratio, it's too high for the wire feed ratio. Travel speed is too slow. How can you prevent it or fix it? Turn your amps down. Increase your travel speed. If you've put a hole in your metal, there are two things you can do. You're going to need to start again from scratch and grab some new metal, or you can just adjust your settings, fill in the hole, grind it down and then weld over it as if it was never there. A lack of fusion occurs when the weld metal doesn't fuse with the base metal properly. You can also have a lack of fusion between multi-pass welds. There are often gaps along the edge of the weld, and it's usually characterized by a high crown weld bead. You might not be able to see how weld's fused on the actual weld, but if you can break it apart by placing it in the vise and cracking it apart, then it wasn't fully fused together properly. You can also check the fusion with an X-ray or other non-destructive methods. So what causes it? Traveling too fast, not enough heat, the torch angle is incorrect, or incorrect joint design or fit up. So how can you prevent or fix it? Increase your amps and slow your travel speed. Wait until a wet pull has formed on the metal before moving and focusing on pushing or pulling it along. You want to be in control of it. Make sure that your joint is lined up properly with the correct size gap. The lack of penetration means that your weld bead hasn't gone all the way through the joint. The groove or root of the metal hasn't been completely fused. This is a lot easier to see on a butt weld, as you can flip it over and check the back side to make sure the weld bead has fused on both sides and filled in the entire space. Like a lack of fusion, if you've ever got shallow penetration, the weld can be deemed faulty for crucial situations. So what causes it? Too small a root gap or a misaligned improper joint fit up. Not enough heat, travel speed too fast. For stick and TIG, your amps could be too low. For MIG, your voltage could be too low for your white speed ratio. Using an electrode that is too large for your root gap, or a poor welding technique. How can you prevent or fix it? Check that you're using appropriate amps, volts, wire speed and traveling at a speed to match. Make sure that you're holding your torch at an appropriate angle with a tight arc. Prep your root gap so that it is not too narrow that you can't get into it, but not so wide that you can't fill it and you burn through. The slag inclusion occurs when a piece of flux falls off the end into the whirlpool but doesn't melt out, becoming trapped inside and contaminating the weld as it solidifies. This only happens with stick and gasless MIG welding. The slag inclusion will typically leave a hole in the weld with the slag exposed. What causes it? Slag wasn't removed prior to the next pass on multi-pass welds. With stick and gasless MIG, using the wrong welding techniques such as pushing instead of pulling. How can you prevent or fix it? Remove the slag before your next pass. Store your fill metals in a cool, dry space, preferably sealed in a container. You can also rebake any damp electrodes before use. Use the proper welding technique, pull or drag the filler instead of pushing, and maintain a good arc length. Spatter is the small balls of metal that surround the weld once you've done. While welding, the sparks that spray from the torch or electrode often include little bits of molten metal, and these are left around the weld once they've hardened. They don't actually cause any harm to the weld, but it certainly adds to your cleanup time after you're done with the weld. Stick and MIG welding are the main welding processes that will produce spatter, and a lot of the time, it's impossible not to create it. What causes it? The amps are too high, the volts are too low, or the wire speed is too high when welding MIG. The arc length is too long. Your work angle, torch position in relation to joint, is too steep. How can you prevent or fix it? Move your torch or electrode close to the joint or shorten the arc length. A good length is 3mm. Readjust your amps or your volts. Use an anti-spatter spray so you can just chip off once you're done, rather than coming back with a grinder. A A weld crater is a dip or a hole at the end of the weld that hasn't been fully filled. Weld craters can happen on any kind of weld. They can often lead to cracking, so filling the end of your weld is very important. What causes it? Quite simply, not enough fill metal deposited in the end of the weld. How can you prevent or fix it? Pause for a few extra moments, or dab extra filler fatigue and let the weld bead build up. Ease off the amp slowly to narrow the weld pool as you come out the weld. Once you reach the end of the weld, backstep to fill in the end. A convex or concave weld bead is generally a sign that something is not quite right with the weld. If the correct settings and technique have been used, the weld should lay flat, as in the miter against the parent metal. And what causes it? A convex bead is caused by not having enough heat to properly flatten the weld at the same time as travelling too slow. The concave bead is caused by too much heat or travelling too fast. How can you prevent or fix it? Adjust your settings and travel speed to suit your parent metal. Unimig machines all come with a settings guide to help you with this. Make sure you're using a proper welding technique, push for gas and pull for gasless. Also, check your torch angle. It should be on a 45-degree angle. Almost every issue you encounter when welding can be prevented with proper preparation. It can seem like a lot of work and hassle, but doing it in the first place will be a lot faster than having to remove a dodgy weld and start again and then still need to be prepped. If you start with dirty metal and a poorly calibrated machine, you're not going to get the greatest weld. So be patient, and if something does go wrong, we can help identify and solve the problem so it can be back up and running in no time. Well, we hope you've learned some valuable tips today. If you have, give us a thumbs up and let us know what tips helped you out in the comments. Be sure to tag Unimig in your welding projects, and we'll catch you next time.